Here we're going to look at question 5 from section 2 of the ENGAA 2018 paper. In this question, we're given the following scenario. We initially have a mass hanging by a Newton meter which reads 3 newtons above a beaker on a set of scales which reads 400 grams. Then the ball is fully immersed inside the water in the beaker on the scale, and the Newton meter reads 2 newtons at this point. We're also told that the weight on the scales is just given by x grams, and then finally the mass on the Newton meter is detached, so it just sits in the beaker of water by itself on the ground, and then we're told that the reading on the scales is given by y grams. The question simply asks us, what are x and y? If you would like to have a go at answering this question yourself, please pause the video now, otherwise let's have a go at it. So let's begin by considering our first diagram. Now here we just have the mass hanging by the Newton meter which reads 3 newtons. So what this means is that the weight of our ball, of our mass, is going to be 3 newtons. So why is this going to be useful? Well, we know that the weight of our ball is just going to be given by its mass multiplied by the acceleration due to gravity. And we know that the acceleration due to gravity is just given by 10 meters per second squared. So we can go ahead and rearrange this equation for our mass and substitute in our value of weight, 3 newtons, and the value of our acceleration due to gravity, 10, telling us that the mass of our ball is just 0.3 kilograms, or 300 grams. So this is going to be useful because then we can go ahead and look at our final diagram, which just shows that we have a ball resting inside the beaker on our scales. Now from the first diagram, we know that the beaker and the water together weigh 400 grams. So the number of grams being read on the scale in the final picture should just be this 400 grams plus the mass of our ball. So, since our ball is just 300 grams, then the reading y should just be 400 plus 300 grams, which gives us 700 grams. Now that we've got our reading y, let's go ahead and consider our second picture and try and find out what x is going to be. So here, the Newton meter only reads 2 newtons because the ball is submerged in the water. So what this means is that 1 newton of our force is being provided by the water in the upwards direction. Just so that there's a total of 3 newtons on our mass, the resultant force is going to be 3 newtons, keeping it where it is. Then, by Newton's third law, we know that there's going to have to be a similar force of 1 newton in the downward direction. And what is this 1 newton going to do? Well, 1 newton in the downward direction is going to be equivalent to the scales of just having a mass of 100 grams inside our scales, because our 100 grams will just provide a force of 1 newton. So the scales isn't going to know the difference between 100 grams and just our 1 newton force downwards from the ball. So what are our scales going to be reading here? Well, they're going to be seeing the mass from the beaker and the water together, and they're going to be including this 100 grams from the 1 newton force on the ball. Therefore, x should read just 500 grams, and then this x equaling 500 grams with our value for y of 700 grams will correspond to answer F given in the question.